Hello and welcome to Scholar Fedu. This is our JAMB prep series where we provide relatively detailed solutions and explanations to the UTME questions. And in this recording, we are looking at the UTME questions for physics for the year 2015. This is the second part of the recording where we are going to look at the next 20 questions. Before we continue, please don't forget to subscribe to our YouTube channel, like and share our content. You can also visit our website at scholar.com to practice the UTME exam for free. Alright, first question here on light. Total eclipse of the sun occurs when sunlight is obstructed from reaching the earth. And how does that happen? That is when the moon comes in between the earth and the sun, and so it obstructs light from the sun from reaching some part of the earth, and that's what we call eclipse. So it happens when the moon is between the earth and the sun and the earth. Next, also on light, which of the following pairs of colors gives the widest separation in the spectrum of white light? Alright, in the dispersion of white light, the least deviated is the red and the most deviated is the violet. So there is the one that has the widest separation in the spectrum of white light is the red and the violet. They have the greatest separation. Next, on motion, which of the following with respect to a body performing simple harmonic motion are in phase, that is in the same direction? The force acting on the body and its acceleration. The force acting on the body and its acceleration are both in phase. They are in the same direction. That is for the body in simple harmonic motion. Next, on equilibrium and moment of force, a uniform meter rule weighing 0.5 Newton is to be pivoted on a knife edge at the 30 centimeter mark. Where will a force of 2 Newton be placed from the pivot to balance the meter rule? Alright, so we try to put what we have here in a diagram. Now the uniform meter rule, we are assuming it is a 1 meter rule, that is 100 centimeter. So the center of balance should be at that 50 centimeter. And that is where the weight of this meter rule is the weight, say W of the meter rule is theoretically supposed to be concentrated. We now have this meter rule balanced on a knife edge at the 30 centimeter, that is at the 30 centimeter mark on this meter rule. And a weight of 0.5 Newton is to be pivoted on the knife edge at this 30 centimeter rule, at the 30 centimeter mark. Where will a force of 2 Newton be placed from the pivot to balance the meter rule? So we have a force here of 2. Now here is the thing actually here is, since this is theoretically the center of mass, the center of mass of this meter rule, it is expected that if you put this thing here away from here, that this meter is going to tilt to this side, it will bend to this side. So in order to balance it, we need to place a force on the other side here. Now we are placing a force of 2 Newton on this side, but we want to know what is going to be the distance of that force from here in order for this meter rule to be balanced. So to do that, we're going to go to what we call the principle of moment, that the sum of the moment in one direction is equal to the sum of the moments in the opposite direction, or we say the sum of the clockwise moments. The sum of the clockwise moments, because this thing is pulling this thing down, so this meter is going to be going like this, like clockwise. So we say that the sum of the clockwise moment is equal to the sum of the anti-clockwise moments. And moment is force, the force times the distance. Force times the distance. So here, if you look at the moment around this place, moment around this place is going to be the force, the weight of this meter rule, W, which is 0.5, times the distance between where this weight is and where this is. Now the weight here is at 50 centimeter, while this pivot here is at 30. So the distance from here to here is going to be 50 minus 30. That means that this weight is 20 centimeter away from where this knife edge has been pivoted. So you are going to have 50 minus 30 times is 0.5 is equal to this 2 Newton here. That's for the moment in the other direction, in the anti-clockwise direction. So this will be 2 Newton times the distance between it and where this knife edge has also been pivoted, which is x. So 50 minus 30 is going to be 20. 20 times 0.5 is 10. That means on this side we are going to have 10, while here is x times 2, that is 2x. So we have 10 is equal to 2x. To get the value by x, we will divide both sides by 2. So when you divide both sides by 2, 10 divided by 2, that will give you 5 centimeter. Okay, so this is the size of that 2 Newton from here. But the question is, where is it going to be placed? That is, on which marking is it going to be placed? So it is going to be placed, sorry, where will it be placed from the pivot? So it's going to be placed 5 centimeter from. Next, on density and relative density. A solid weighs 10 Newton in air, 6 Newton when fully immersed in water, and 7.0 Newton when fully immersed in a certain liquid X. Calculate the relative density of the liquid. Alright, from the question we have the weight in air as 10 Newton, the weight in water as 6 Newton, and the weight in a given liquid X as 7 Newton. The relative density is going to be the change in the weight, or the difference in the weight, okay, in the liquid over the difference in the weight in water. Okay, so in air it was the weight in air is 10, the weight in that liquid is 7. So the difference in the weight, okay, in the liquid is going to be 10 minus 7 divided by the difference in the weight in the water, and that will be 10 minus 6. So you have 10 minus 7, 3 over 10 minus 6, which is 4. So here we have the relative density to be 3 over 4. Next, the diagram above shows a maximum and minimum thermometer divided into 3 portions: P, Q, R. Which of the following is true about the respective content of P, Q, and R? So the content is the maximum and the minimum thermometer, okay, by standard, is also called the 6 thermometer. It contains 2 columns of alcohol separated by a column of mercury. 2 columns of alcohol separated by a column of mercury. So the column of alcohol is this. Okay, this is the column of alcohol, the first column of alcohol. This is the second column of alcohol, and both of them are separated by a column of mercury. Okay, so the constituent or the contents here of these regions I have here is, here we have alcohol, mercury, and alcohol, or we say alcohol separated by a column of mercury. So we have alcohol, mercury, and alcohol. Next, on nuclear physics, the process of energy production in the sun is by nuclear fusion. Okay, by nuclear fusion. Okay, the nuclear fusion of hydrogen isotopes and helium. Next, the particle responsible for nuclear fusion in a nuclear reactor is the neutrons. Okay, the neutrons, they are responsible for nuclear fusion in a nuclear reactor. Next, on modern physics, if the uncertainty in the measurement of the position of a particle is 5 times 10 raised to the power minus 10, the uncertainty in the momentum of the particle is, so I require to calculate the uncertainty in the momentum of the particle, and we are given the Planck's constant here as 6.6 times 10 raised to the power minus 34 joules. So from Heisenberg's uncertainty principle, we have the uncertainty in determining the momentum times the uncertainty in determining the position is greater than or equal to h. Okay, this is what we have from Heisenberg's uncertainty principle. Now here in the question, they've given us the uncertainty in determining the position, that is this delta x here. They give us to be 5 times 10 raised to the power minus 10. So we just substitute that here, okay, times this here, the uncertainty in determining the momentum, which is what we are required to calculate in the question. So we say this is greater than or equal to, okay, the Planck's constant, which is 6.63 times 10 raised to the power minus 34. To get the value of this p here, we are going to divide both sides here by 5 times 10 raised to the power minus 10. So you have delta p to be equal to the Planck's constant divided by this. Now how do we do this division here? we simply divide the whole part, then divide the other part with indices, with index. Okay, so we just say 6.60 divided by 5, that is 1.36 times, then we now use our law of indices for these two here, meaning we are having 10 raised to power minus 34 divided by 10 raised to power minus 10. So how do we do that? Now if I have from law of indices, if I have 10 raised to power x divided by 10 raised to power y, 10 raised to power x divided by 10 raised to power y, that will be equal to 10 raised to power x minus y. Okay, since they have the same base, then I'll just take that base that is common, that I'm going to subtract the power. Okay, that is for division. So here we have 10 raised to power minus 34 divided by 10 raised to power minus 10. This will be equal to what? 10 raised to power minus 34 minus the power here minus 10. Okay, I'm going to have 10 raised to power, let me write this out. So I have 10 raised to power minus 34 over 10 raised to power minus 10. This will be equal to 10 raised to power minus 34, okay, minus this, then minus 10 that I have here. So this will be equal to 10 raised to power minus 34. Okay, minus times minus is plus, then we have 10. Okay, so this is equal to 10 raised to power minus 34 plus 10 is minus 24. All right, so this is it. Now you cannot see me writing this. All right, so this is 10 raised to power, what I have here, 10 raised to power minus 34 divided by 10 raised to power minus 10. All right, this will be equal to 10 raised to power minus 34 using the law of indices. Okay, minus 10 here. So this is 10 raised to power minus 34, minus times minus is plus 10. So you have 10 raised to power minus 34 plus 10 is minus 24, and that's what we have. We have a website at scholar.com where you could practice exams for free, the UTME exam and the post UTME exam. It also features modular quizzes in physics, chemistry and biology. So if you've studied a topic in any of the subjects and you want to test your understanding of the topic, you can head on to our website at scholar.com and take modular quizzes for free. Also, if you sign up on the website, it has a personalized dashboard where you could use to check your progress in learning. We also have interactive sessions on the website and on our social media platform. Freebies are also available to top performance on the website. Next, on density and relative density, the change in volume when 450 kilogram of ice is completely melted is, here we have the density of ice and the density of water. Alright, so density, okay, is equal to, the formula for density is mass over volume. Okay, mass over volume. To make my mass subject to the formula here, I'm going to cross multiply this volume. So now I'm going to have density times volume is equal to mass. So mass is equal to density times volume. If it is volume that I want to make the subject of the formula, I will divide both sides here by density. Okay, by density. So volume will be equal to mass divided by the density here, represented as this symbol O. Okay, now when a substance is converted from one form to another, like from, let's say, solid to liquid, the mass of that substance will still remain the same, but the volume can change. Okay, the volume may change, but the mass is going to remain the same unless some of the particles of that substance has been lost in the process of conversion. Okay, but the mass, if no particle is lost, okay, is going to remain the same. So what we are saying is that the mass of the ice, okay, the mass of the ice and the mass of the water is the same thing. Okay, when this ice completely melted, its mass did not change. All right, so we can say that our M1, like Mi, mass of the ice, is equal to Mw, mass of, the water. Okay, now V1, Vi rather, that is the volume of the ice, is now going to be equal to, remember that volume here is equal to mass over density. Vi is going to be equal to mass over the density. Okay, the density of the ice the mass of the ice by the density of the ice. The mass of the ice is going to be 450, as we have from the question, divided by its density, which is given here as 900. 450 divided by 900, that is 0.5. The volume of the water is going to be equal to the mass of the water over the density of the water. The mass of the water is going to be the same as the mass of the ice, okay, assuming that no particle was lost in the melting of when the ice was melting into water. So we're going to have 450 divided by the density of the water, which here is given as 1000, okay, as 1000. So we have 450 divided by 1000, and that is 0.45, okay, is 0.45. Now 450 divided by 900, this is 900, not 9000, 900, this is 0.5. Now where V1 and VW, as we've stated, are the volume of the ice and the volume of the water, and this is the density of the ice and this is the density of the water. So the question is to find the change in the volume. So the volume of the ice is 0.5, the volume of the water is 0.45. If you look at these two, you can see that the volume of ice is greater than what the volume of water here, okay, because ice as it is think of ice as puffed water, okay, like water that is puffed, okay. So if you have ice and water of the same mass, the ice would be bigger, okay, so have a greater volume than the water. But basically it's back to the question. So we have the volume of the ice at 0.5, the volume of the water is 0.45 here. The difference in the volume, the change in the volume, is now going to be the original volume of the ice minus, or let's say the volume of the water when it was ice minus the volume of the water, when the ice melted. So that will be 0.5 minus 0.45, and that is equal to 0.05 meter cube. Next on matter, when impurities are added to semiconductor conductivity, the addition of impurities to semiconductor is what we term as doping. What's termed as doping? And the purpose is to increase the conductivity. So doping is, like I said, the addition of impurities or dopant to semiconductors to increase its conductivity. So the conductivity will increase, then it will decrease as the impurity depletes. Next on photoelectricity, the process through which free electrons leave the hot surface of hot metal is known as, that is called thermionic emission, okay. It is the liberation of free electron from the surface of a strongly heated metal, okay, from the surface of a red hot metal. Next on optics, the production of pure spectrum could easily be achieved using to produce a pure spectrum of white light, you are going to need a prism and two convex lenses. This is the illustration here. If you look at this diagram is for the experimental setup to produce a pure spectrum of light. And as you can see in this diagram, we are having a rectangular prism here and two convex lenses, okay, a rectangular prism and two convex lenses. So, and if you want to put a purely pure spectrum, you also have like two lenses and two convex lenses too, okay. So whether it is purely like fairly pure, or it is simply pure, like a pure spectrum, okay. But if you are creating an impure spectrum, then you are not going to need another convex lens here. You won't be needing another convex lens. You have only one convex lens. But to produce a pure spectrum, you need a triangular prism, a triangular glass prism. You need all of these things here basically, but from we've narrowed it down to this question here. It's just a triangular glass prism with two convex lenses. Next on electrostatics, a short chain is sometimes attached to the back of a petrol tanker. So this is to conduct excess charges to the earth, okay, to prevent the accumulation of charges, okay, which may lead to can lead to explosion of that petrol tanker. So those chains are added, or they are attached to the back of those tankers in order to conduct the excess charges, okay, from electrostatics to the earth. Next, a perfect emitter or absorber of radiant energy is the black body is a perfect emitter or absorber of radiant or light energy. You can also join our online tutorial classes for different classes. We have tutorials for students in SS1, 2 or 3. We also have for UTME candidates, for JAMB candidates, for students who want to write the JAMB or the UTME exam, and for those who want to have the post UTME exam after the UTME exam, and also for candidates that are sitting for WAEC exam or GCE or NECO. And we offer this tutorial on various platforms, so you could join us on WhatsApp or on Telegram, it could be on Zoom or on Google Classroom. So we have various platforms where we take our tutorial. The links to join the platform are available on our website at scholar.com, or you could also check it out in the video description below. Next question. So here we have 6 identical cells, each of EMF 2 volts, okay, that are connected in series as shown above. We have to find the effective EMF of the cell. Okay, so let's see the total EMF. Alright, that will be obtained by simply adding up the EMFs that we have here. Okay, so you have 2 plus 2 plus 2 plus 2 plus 2 plus 2, so you have like 6 of that, so that's like 6 times 2. Okay, so you have 12 volts. That will be the effective EMF of this. Next, on work energy and power. If a pump is capable of lifting 500 kg of water through a vertical height of 60 meters in 15 minutes, the power of the pump is, alright, so power is equal to energy over time. Alright, and the energy here, let's say the work done. Okay, work done actually is what we have here. That is the work done in lifting this body, this mass of water through this height. Okay, now the formula for work is is force times distance. Force times distance. But in this case, the force is going to be the weight of that water that is being lifted, while the distance is going to be the height. Okay, the height to which that water was lifted. So we are going to have weight as mg. Okay, weight as mg, and the distance as h, the height. Our mass, the mass of the substance here, of the water here, is 5,000 kilogram. The height through which it was moved, okay, which is serving as like the distance here, is 60 meters. Now we are given the time in minutes. Okay, in minutes. And if we check the units that we have here, what we have here featured is seconds. Okay, so there's a need for us to convert this time from minutes to seconds. To convert from minutes to second, we multiply by 60. So this will be 15 multiplied by 60, and that will give us 900 seconds. So this is the value we are going to use in our formula. Now the value of the acceleration due to gravity, which you have here, this g here, is approximately 10 meters per second. Sometimes this may be given in the question, sometimes it's not given. So if it is not given, you can take it to be, if need be, you can take it to be 10 meters per second, and sometimes we use the value 9.8 for it. Alright, so substituting these values that we have here into the formula, we now have mass 5,000 times g, which is 10, times the height, which is 60, divided by 900. So by the time you multiply all of this and divide by 900, you'll be getting 3,333.33. Okay, if you write this in standard form, this is 3,000. This is like saying 3 times 1,000. Okay, so you just write this as 3.3 times 1,000 times 1,000, which here is 10 raised to the power 3. 10 raised to the power 3 means 10 times 10 times 10, and that's 1,000. Of course, by the time you multiply this by this, we'll be getting something close to this. Okay, so basically we can write this in standard form as 3.3 times 10 raised to the power 3. Okay, next, on waves. The distance between two successive crests of a wave is 15 centimeters, and the velocity is 300 meters per second. Calculate the frequency. Alright, so we know the formula, okay, showing the relation between velocity of a wave, frequency of a wave, and wavelength. That is v is equal to f lambda. But we are looking for frequency here, so we are going to divide both sides here by lambda to get the value of f here. So f here is equal to v over lambda, like v divided by lambda. Now from the question, the velocity of the wave is 300 meters per second. We have that. The wavelength is 15 centimeters. Now there's a problem here, in that the unit of our wavelength here is in centimeter, but the unit of the velocity here is in meters per second, and this is the focal point here. We have meter here. Okay, we need to balance our units before we can use this formula. You cannot use centimeter with meter directly. Okay, so we need to convert this from centimeter to meter, okay, to balance the units. So to convert from centimeter to meter, you divide by 100. You divide whatever you are given in that centimeter by 100 to get its equivalent in meter. So you say 15 centimeter divided by 100, and that is equal to 0.15 meter. So we just substitute that like this values now into this equation here. So the frequency F is equal to the velocity 300 divided by the wavelength, which is 0.15. Now one thing I should mention is, of course, in the question they did not mention wavelengths, right? They didn't say this is the wavelength, but they said the distance between two successive crests. That defines wavelength for a transverse wave. Okay, the distance between two successive crests of a transverse wave or two successive trough is what we call wavelength. Alright, so this is indirectly, okay, our wavelength, or we can say directly by definition. So back to what we have here, 300 divided by 0.15, that will give us 2000, and we can write this 2000 as 2 times 1000, like 2 times 1000, and 1000 is just 10 raised to power 3. That's 10 times 10 times 10. So this is raised to power, not just like 1.5, not just 3. It's supposed to be power, like a superscript here, 2 times 10 raised to power 3. Next, on electricity, an electric lamp mapped 240 volts 60 watts is left to operate for an hour. How much energy is generated by the filament? The electrical energy generated by the filament is given as Q equals power times time. Okay, power times time. Now the time here, okay, is given in hours. We convert it to seconds. So how do you convert from hour to seconds? First, we are going to convert to minutes. 1 hour is 60 minutes. Then we convert from minutes to seconds. 60 seconds is 1 minute. So 60 minutes is going to be 60 times 60 seconds, and so that is 3600. So we have 1 hour is equal to 3600 seconds. The power from the question here, okay, is given 60 watts. Okay, watts is the unit for power, so this is 60 watts. So we then substitute this in the formula here. So you have Q to be equal to the power 60 times the time, which is 3600, and this will give us 21,600. 21,600. If we write this in so it is 216,000. Okay, 216,000. If we write this in standard form, we'll be having 2.16 times 10 raised to power 5. That's like saying this is 2.16 times 10 raised to power 100,000. Okay, 10 raised to power 5 is 100,000. Next question on optics. In comparing the camera and human eye, the film of the camera functions as the. So in a camera, the film is where the image is formed. Okay, the image in the camera is formed on the film, and in the eye, the image is formed on the retina. So the function of the retina and the film is analogous. Okay, so images are formed on the retina in the eye, and on the film in the camera. Okay, don't forget to check out our playlist. We have different playlists. We have for full solutions to UTME or JAMB questions and in physics, chemistry and biology. We also have for modular quizzes as well. Okay, we'll also have a playlist for post UTME or post JAMB exam, and also for crash courses in physics, chemistry and biology. So don't forget to check out our playlist for the available videos. So that's it for this recording. Thank you very much for watching. Please don't forget to subscribe to our YouTube channel at Scholar Fedu. Okay, like and share our content, and visit our website at scholar.com to practice UTM exam and modular quizzes for free. Thank you.